Lesson 2-6, graphing in 4 quadrants. So let's look at a coordinate graph. A coordinate graph is made up of 2 number lines intersecting. All right, so the first one we look at is the horizontal number line, and that is the x-axis. And then it intersects right here at 0. The vertical number line is the y-axis. And what happens, it splits the plane into 4 sections, and they're called quadrants. That beginning prefix quad means 4. So you might have a quad at home that you ride. It has 4 wheels. So same idea. All right. When you're talking about quadrants, you always start up here in the upper right-hand side. That's the beginning. That's the beginning of it. And the reason that is because the x's are positive, the y's are positive. That's the most commonly used quadrant. When you talk about real-world problems, sometimes you don't even use these. You only deal with that first one. So that's why that one is quadrant 1. And when you look at these, I want you to be able to number them or name them with Roman numerals. That's how they're numbered. This is quadrant 1, a capital I. And naming quadrants goes counterclockwise. So it goes opposite of the clock. So quadrant 1 is the upper right. Quadrant 2 goes to the left. Then there's quadrant 3 down here. And then quadrant 4 is an I with a V. That's quadrant 4. So you can be able to number those with Roman numerals and be able to identify them, because when you plot the points, they're going to ask you what quadrant it's in. When you graph ordered pair, just like we did earlier last week or the week before, I can't really remember, it's always the set with parentheses around it. The x-coordinate is first, the y-coordinate second. You do always the x first. It's kind of in charge. It tells you where to go left, right, and the y where to go up or down. Now, this right here is not supposed to be like a little owl face. It's representing what the ordered pair look like. So in this upper right hand, or quadrant 1, then the x is positive and the y is positive. But if we go over here to quadrant 2, the x is negative and the y is positive. Down here at 3, quadrant 3, boy, that really does look like an owl face when you think about it. Sleeping, right? Do you see that? Yeah. They're both negative. And then down here at 4, we have positive for the x and negative for the y. I wasn't going to say that, but yeah, or else it looks like something happened to that eye and he's got a little patch over it or something. Anyway, yeah, so that is the way the quadrants work in the coordinate graph. Let's do this. Let me switch over here just briefly and look at our quadrants. Okay, so here is 1. Here is 2, 3, and 4. So if we had to plot -3, 4, you always start at the origin and you look at the x-coordinate first. So we would go left 3, but the y is positive 4. So up 4, and we place our point. Now if it's labeled, so let's say they tell us that's point A, then you would have to label point A. You might also have to identify what quadrant that's in. So after you graph it, you just come back over here and say it's in quadrant 2. Okay, so let's say we had to do -1, -6. So you would start at the origin again. The x is -1, so you go left 1. The y is -6, so you go down 6. Let's say that's point B, and then you'd say that point B is in quadrant 3. Well, what if you have to name the quadrants and they tell you to plot C, and C is at 3, 0. Well, you start on the origin, and then the x is positive 3, but the y is 0, so you stay there. What quadrant would you consider that in? Anybody know? Trayton?
I think it's you.
Correct. It's no quadrant. So you could say none, or you could say that it's on the x-axis, and you would be correct either way. Okay? So if you're asked to name the quadrant and it's really not on one, you can say none, or you can name what axis it's on. All right, any questions about that? So that stuff you have done before. Let's go back to this. Here's something you may or may not have done before. So we are looking at graphing an equation. Okay, graphing an equation. This equation is of the form y equals x minus 6. It's similar to the function tables that we have used before, okay? It's similar to the function tables that we've used before. They've given us the values for x to plug in, 3, 2, 1, 0, negative 1, negative 2, and we've got to figure out the matching y, and then we've got to figure out the ordered pair. So what you will do, we'll start with x being 3. So I'm going to plug in y equals 3 minus 6. So that means I have 3 and I go back 6. What would the result be? Tori? Negative 3. So I'm going to fill in my table negative 3, and my xy, my ordered pair, would be 3, negative 3. And I'm going to go ahead and graph that. 3, negative 3 would be right here. Next, I go where x is 2. I plug it in. I'm going to do it over here on the side, and that's what I'm going to have you guys do in your assignment today. Y equals 2 minus 6. If I have 2 and I lose 6, where would I be? Shane? Negative 4. So my matching y is negative 4, so 2, negative 4. So I'm going to go over 2 and down 4. 1. X is 1. So y equals 1 minus 6. Oh, that's not what I wanted to do, was it? Y equals 1 minus 6. And what would that be? If I had 1 and I lose 6, Layla? Negative 5. So, Layla, what's my ordered pair?
It would be 3 or 0, negative.
No, I'm in this one.
1, negative
1, negative 5. So I go over 1 and down 5. And now I've got 0, so y equals 0 minus 6. And if I'm at 0 and I go back 6, that would be negative 6. 0, negative 6. And I think that one's already graphed there for me. Now, here's the tricky one. Negative 1. Y equals negative 1 minus 6. So I'm already 1 in the hole, and I go back 6. What's it going to be?
Negative 7.
Negative 7. Are you seeing a pattern here?
Mm-hmm.
Yeah. Thinking there should be some kind of pattern on all these. So negative 1, negative 7. And then finally, negative 2. So y equals negative 2 minus 6. So I'm in the hole 2 already, and I got to go back 6 more. So what would that be, Stephen?
Negative 8.
Negative 8. And my ordered pair, negative 2, negative 8. And I graph that.
It's like a negative.
Well, let me ask you this. Let me do this with a different color. Okay. You could graph this. What kind of function did this come out to be? Describe what that would be.
Negative.
No. Not negative.
Oh, you positive.
It's positive, but what does it draw? What is that?
Straight line.
A line. This is called linear. And as Trayton said, it's positive because it is going uphill from left to right. But that is a linear function. The ones that you would be graphing today would be linear functions. And it's just like what I've told you in the past. If one of your dots or two of your dots are way out in left field, they're not in that line, what should you do? If they don't line up, what should you do? Huh? Redo it. You did your math wrong somewhere. These are all going to be in a line. Okay? These are all going to be in a line. You plug in your x and you solve for y, and that's your set for an ordered pair. You graph them, and then they are linear, and that is a positive slope. Now, he was referring to negative. He was thinking about ones that might look like that. If they go downhill from left to right, yeah, that would be a negative. Okay, oops, I just lost the whole thing. There we go. All right, are there any questions? Okay.